Let us study chemistry together with CBSE Chemistry tips and tricks.
A cell of EMF E is connected across an external resistance R. Okay, so we have a cell of EMF E is connected across a resistance R. Correct? Okay, when current I is drawn from the cell, okay, right? The potential difference across the electrode of the cell drops to V. Okay, right? That is terminal voltage V. You have to find the internal resistance. And they have given the options. Okay. Now, when current is taking from the battery, we know the equation for V is what? Terminal voltage is equal to E minus IR. During discharge or when current is taken from battery, the equation for potential difference or terminal voltage is equal to E minus IR. So what is IR? IR is equal to E minus V. Correct? Now what is R? We are supposed to find R, right? E minus V by I. Correct? But there is no option like that. So what we have to do? We know that I, according to Ohm's law, I is equal to what? V by R, right? Okay. So substitute that R is equal to E minus I by, instead of current, instead of I, put what? V by R. Okay, V by R. Clear, right? Hope all of you understand how this R comes to the numerator. V by R, right? That R on the denominator will come to the numerator, right? Okay. Denominator of the denominator comes to the numerator. V by R. Okay, that R will come to the numerator. So E minus I by V into R. So which option? It is very clear. Option D. Option D is the right answer. Hope all of you understand. The storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, the maximum current that can be drawn from the battery will be. Okay. So here current is drawn from the battery, right? In that case, what is the equation for V? V is equal to E minus IR. We are supposed to find current, right? So instead of voltage, I am going to write IR according to Ohm's law. So what is that? E minus IR. Okay, right? So see, I am taking minus IR to LHS. So IR plus IR is equal to E. Correct? So I into R plus R is equal to E. Correct, right? Now what is equation for I? I is equal to E by R plus R. Now what we have to find? Maximum current, right? Maximum current. Maximum current happens when external resistance is equal to 0. That scenario normally we call it as short circuit. Short circuit. Okay, short circuit. In such cases, the entire EMF is dropped across the internal resistance. So now R becomes 0, then I become I max. So what is that? I max is equal to E by internal resistance. Correct. So what is EMF? It's given in the question. 12. What is internal resistance? 0.4. You divide it, you will get 30 ampere. Hope all of you understand. It's a nice question. Hope all of you understand. Check it. Two sources of equal EMF are connected in series. This combination is in turn connected to an external resistance capital R. The internal resistance of the two sources are R1 and R2. Okay, so we have first cell, EMF is E, internal resistance we can say R1, and see, first one E1 is E, second one E2 is also E, because equal EMF, right? But internal resistance are different. This is R2. Okay, they are connected in series and you also have a resistor capital R. Okay, they are connected to an external resistance R like this. Now as per the question, R2 is greater than R1. If the potential difference across the source of internal resistance R2. See, potential difference across this cell is what? 0 as per the question. Then what is the value of R? First of all, you have to understand that if the voltage across a particular cell is 0, it means that the entire EMF of that cell is used to overcome the internal resistance. That you keep in mind. As per the question, see, the voltage across second cell is what? 0. What is the meaning of that? The meaning is the entire EMF, which means E2, is, or E we can say, E of the second cell is completely used to overcome what? To overcome its internal resistance. Okay, right? Okay. Here, two cells are connected in series. So, what is net EMF? Net EMF is E1, which is E, plus E2, that is also E. So, what is that? 2E, right? Now, what is the total resistance in the circuit? It is, you have external resistance capital R plus internal resistance of the first cell plus internal resistance of the second cell. Our task is to find capital R, okay? If the voltage across the second cell is 0, we have to find R. Okay, now what is current? According to Ohm's law, what should be that? ES by RS, correct? What is ES? It is 2E. And what is total resistance? It is R plus R1 plus R2, correct? No doubt, right? We can put this as equation number 1. Now, as per the question, it says that the voltage across second cell is 0. So, if I write like this, for cell 2, you know the basic equation, fundamental equation is V is equal to E minus IR2. This is for cell 2, okay, for cell 2. As per the question, voltage is 0. So, 0 is equal to E minus IR2. So, R2, okay, R2. So, what is E? E is equal to IR2. So, what is I? I is equal to E by R2. Clear, right? And we can put this as equation number 2. Now, from equation 1, you have an equation for current, right? This one. From equation 2 also, you have an equation for current. Now, equate the RHS. Because LHS same, right? LHS is current. So, equate the RHS. So, what you will get? We will get like 2E by R plus R1 plus R2 is equal to E by R2. Correct? Now, cut E and E. So, what you will get? 2R2 is equal to R plus R1 plus R2. Correct? So, what is R? R is equal to 2R2 minus R1 minus R2. So, what we will get? We will get like 2R2 minus R2 is R2. So, R2 minus R1. And that is our final answer. Very good question, okay? Very simple, very good and standard question. Check it, okay? And the key point or the key thing is this one. The potential drop across the source of internal resistance R2, which means for cell 2, V value is 0. That's a key point here. Hope all of you understand. Draw VI graph, means voltage current graph, for a cell of EMF E, internal resistance small r, and connected across external resistance R, and explain its significance. So we have to plot a graph between voltage and current for a cell of internal resistance small r. Correct? So what is the equation? C for cell V is equal to E minus IR. Right? See, whenever you draw a graph, always check whether that equation is comparable with the equation of straight line. So I'm going to check that. On y-axis we have voltage, correct? Now x-axis we have what? Current. Now along with current you have a constant, so M. Now you can see there is an intercept. There is another constant here, so C. So this is the equation for straight line. and that is perfectly comparable with the equation for voltage of a cell, right? See, y-axis we have V, x-axis we have current, then you can see a constant along with x, and as an intercept you can see E here. So plot the graph. Okay, so voltage on y-axis, on x-axis we have current, right? You are going to get a straight line, right, in such a way that what is y-intercept? Y-intercept is E, which is a positive value. So positive side of the y-axis, positive y-axis, E. This value is E. You are going to get a straight line with negative slope. And what is the slope? What is M here? What is M here? M is minus R. Clear, right? Minus R. Okay. So a straight line with a negative slope. Correct. So slope of this graph is minus R. Hope all of you understand. What is the significance of this graph? See, from the y-intercept of the graph, that is this point, you will get what? EMF of the cell, right? Okay, so y-intercept will give you what? EMF. EMF is the maximum voltage of the cell, right? When no current flows through the cell. Correct. Now, see, minus slope will give you what? Internal resistance. Internal resistance. Correct, right? Slope is minus R. So, minus slope will give you internal resistance. Y-intercept will give you EMF. Negative of the slope will give you what? Internal resistance. Clear? So, that is the significance of this graph. Okay. Hope all of you understand. When you draw the graph, you can touch this line on the x-axis. Okay. Then it will be perfect. Okay. The plot of the variation of potential difference across a combination of three identical cells in series versus current is shown below. What is the EMF and internal resistance of each cell? That is the question, right? And they have given the graph. They have given the graph of voltage versus current for a cell, right? Then no doubt go and write the equation for voltage of cell. Okay, what is that? V is equal to E minus IR. And you can see the graph is a straight line. So you write the equation for straight line. What is that? Y is equal to mx plus c, right? So y-axis you have what? Voltage. X-axis you have what? Current. What is the slope? Slope is minus r. And what is y-intercept? That is c. It is E, right? Correct. So what is E? E is y-intercept. Now check the graph. Check the graph. Okay, check the graph. What is y-intercept? Okay, the point where the graph touches the y-axis. It is very clear. 6 volt. Perfect. Clear, right? Now one important thing here, how many cells we are using? We are using 3 identical cells, which means all of them have same EMF, right? In series, correct? So here it is actually ES, correct, right? Now we have 3 cells in series. So what is the net internal resistance? We can say RS. Clear, right? ES and RS. Okay, so ES we got. It is 6 volt. Now what is ES? ES means E1 plus E2 plus E3 because we have 3 identical cells, which means 3E is equal to 6 volt. Correct, right? So what is EMF of one cell? EMF of one cell is equal to 6 by 3, that is 2 volt. Hope all of you understand. So we got the first one, EMF of each cell, that is 2 volt. Clear, right? Okay. So here you can add ES and RS. Okay. So we find EMF of each cell. Now we have to find internal resistance of each cell. See, it is very clear that slope is equal to minus internal resistance, right? minus net internal resistance. Correct. So first we can find the slope and then find the negative of it. So what is slope? For a straight line graph, you know slope is equal to y2 minus y1 by x2 minus x1. Right. So this is the graph, right? So this is the second point and this is the first point. Second point, what is y2 value? It is 0. What is x2 value? It is 1. For this point, first point, what is y2 value? Y2 value is 6. And what is x2? X1 value? X1 value is 0. Substitute it. Okay, so y2 is 0 minus, what is y1? Y1 is equal to 6. X2, see this is point number 1, okay, sorry, point number 2, and this is point number 1, okay. 0 minus 6 by x2, what is x2? 1, minus, what is x1? 0, okay, so what is that? Minus 6, okay, and what is internal resistance? R series is what? Minus of the slope, so what is that? Minus of minus 6, so what is that? 6, right? Now you have 3 identical cells in series. So resistors are also in series, right? Okay. As it is identical, you can say Rs is equal to R1 plus, that is small r, plus R plus R. R1, R2, R3, everything is R only, right? And that is equal to 6. So 3R is equal to 6. So what is R? 6 by 3, that is 2 ohm. Hope all of you understand. Very easy, right? So you can expect this question, okay, for your exams. Hope all of you understand. Under what condition will the current in a wire be the same when connected in series and in parallel of n identical cells, each having internal resistance small r and external resistance capital R? Before doing that question, you must have some fundamental ideas. Okay, you know for cells, V is equal to E minus IR. And V is what according to Ohm's law? It is IR. Right. So E minus IR. So IR plus IR is equal to E. So what is I? Or I into R plus R is equal to what? E. So you can write I is equal to E by R plus R. This you must know. Okay. So the equation for current for a cell of internal resistance R and EMF E is what? I is equal to E by R plus R. That is the first thing you must know. Second thing is, if the cells are identical, then ES, net EMF of the cell is what? NE. E1 plus E2 plus E3 like that, right? But E1 equal to E2 equal to E3 equal to E. Then if you add, what you will get? NE. Keep that point in your mind, okay? And what is total internal resistance? That is NR. Okay? If the cells are identical, then RS is equal to NR. All those things you must know, okay? Then only you can do this question. Now regarding parallel combination, if we are using identical cells, then EP will be E only. Remember it, very, very important. Now what is RP? RP is equal to R by N. R by N. Okay. For understanding, just for your understanding, I will show. Assume you have two cells. Okay, so two internal resistance. So 1 by RP is what? 1 by R plus 1 by R. So what is that? 2 by R. So RP is what? R by 2. Correct, right? R by 2. If it is 3, R by 3. If it is N, R by N. Like that, okay. So we are moving to the question. Before that, you check this. If you want, you can write all this datas. Okay, if you know this, that question is very, very easy. Okay. Here, what is the scenario? Here, we have two cases. Case number 1, we have N identical cells connected in series, which is further connected to a wire. Current is developed in the wire. Second, N identical cells connected in parallel, further connected to a wire. Current is developed there also. Okay, under what condition will the current in series combination equal to current in the parallel combination? We have to identify the condition. Right. Now, what is the total EMF in series combination, as the cells are identical, you now know, right? It is Ne. What about parallel combination? Ep is, as it is identical, Ep will be E only, right? Now what is net internal resistance? It is Nr. And what about here? Net internal resistance is R by N. Correct, right? Now what is the current here? Current. Okay, what is that? You already know it is E by R plus R. But here EMF is Ne, internal resistance is Nr. Now what is Is? Similarly, we can write E by R plus R by N. Correct. Now what is the question? As per the question, current in series and parallel combination are same. Okay, sorry, I write Is here, make it Ip. Okay, Ip. Ip is equal to E by R plus R by N. Now as per the question, Is is equal to Ip. So what we can write? Ne by R plus Nr is equal to E by, see, I am just rearranging the denominator here. So it will be like N. See this part, okay, this part I am going to do. See that I will do separately here. R plus R by N, right? So it become what? Nr plus R by N, correct? Okay, so what is that? Nr plus small r by N. And you know, denominator of the denominator will comes to the numerator. Correct, right? So what is that? Ne by R plus Nr is equal to Ne by Nr plus R. Correct? Now you can cut this, right? Okay, actually you can directly take the reciprocal, but if anybody have doubt, I will do that step also. 1 by R plus Nr is equal to 1 by Nr plus R. Correct? Now take reciprocal on both sides. So what is that? R plus Nr is equal to Nr plus R. Right? So take capital R to the LHS. So R minus Nr. And take both small r to the RHS part. So small r minus Nr. Right? Now capital R outside. 1 minus N. Small r outside. 1 minus N. Okay, right? 1 minus N. 1 minus N. 1 minus cancel. So what you are getting? R is equal to small r. So what is the condition for current to be same? Capital R is equal to small r. Hope all of you understand. Standard question. Okay, very, very important question. Check it properly. In a DC circuit, the direction of current inside the battery and outside the battery respectively are. Okay, they have given 4 options. You go through that. So we have a cell. Okay, we have a cell here. Now it is connected to a wire of resistance R like this. And we already know the direction of conventional current in an external circuit is from positive terminal to negative terminal. So this is the direction of current in the external circuit. So in the external circuit or outside the battery, it is from positive to negative. No doubt in that, right? Now inside the battery, what is happening? See, inside the battery uses its chemical energy to push electron from positive terminal to negative terminal. Inside the battery, the chemical energy, by using the chemical energy, electrons are pushed from positive terminal to negative terminal like this. Electrons will be flowing in this direction. And we know direction of current is opposite to that. So what is the direction of current? Current will be flowing from negative to positive inside the battery. Okay, inside the battery, the direction of current is what? From negative to positive. Negative to positive. Clear? Actually, it's a very good question. So this is our answer. C. Option C. A 10-volt cell of negligible internal resistance is connected in parallel across a battery of EMF 200 volt and internal resistance 38 ohm as shown in the figure. What is the value of current in the circuit? For doing this question, you must know a fundamental data about cells or series combination of cell. Okay, I will explain that first. If the cells are connected like this, positive, negative, then positive, negative, then positive, negative like this. Okay, then what is E net or what is E series? It is E1 plus E2 plus E3. Correct, right? Now, assume that the combination is like this. Positive, negative, then negative, positive, like this. Okay, so cells here are opposing each other. Listen. Positive to positive, negative to negative. If the connection is like this, then what is ES? It will be, if assume E1, E2, now E1 is greater than E2, then E1 minus E2 will be E series or E net. Clear? That is very important, okay? For doing the question, this is very important. Now, check our figure. Here you can see positive is connected to positive terminal of the battery and negative to negative, which means cells are opposing each other. So what is ES? Okay, E bigger one. Here it is E2 minus E smaller one. Correct, right? E2 minus E1. So what is that? 200 minus 10. So what is that? 190. Clear, right? Now what we have to find? Current. What is the value of current? It's easy, right? ES or E net by R net. Here what is the only resistance? It is internal resistance, right? R. What is that? 38. So 190 by 38. And your answer is what? 5 ampere. Very, very simple, okay? Comparing to other EMF question, this is very simple. Why is the EMF of a cell always greater than its terminal voltage? If you check a battery, you can see that there is a positive terminal where potential is high and a negative terminal where potential is less. Now, what is potential difference? Potential difference is the difference of potential of the positive terminal and potential of the negative terminal. Listen carefully. I am going to explain the things in detail so that you will get a clear distinction between EMF and terminal voltage. Okay, for understanding, now there is no wire, so current is not taking from the battery. Assume that here on the positive terminal, potential is 20 volt. And on the negative terminal, it is minus 10 volt. So if I ask you what is the potential difference, what you will say? 20 minus 10, right? So what is that? 30 volt. So this is the potential difference between the terminals of battery when no current is flowing. And by definition, what is that? EMF, right? So this is EMF. So what is EMF? 30 volt. Also we know EMF represent what? The maximum work the battery can do per unit charge. So this battery can do a maximum work of what? 30 joule, right? Okay, now what we are going to do? We are going to connect, see this positive terminal and negative terminal, correct? And remember the battery can do a work of what? 30 joule maximum, right? Now, current is flowing through two regions, right? One is outside the battery where we have external resistance and inside the battery where we have internal resistance, right? This 30 joule of battery, okay, will be using for two purposes. One is to develop current in the external circuit or in the wire by overcoming what? The external resistance. Plus, to develop current in the internal circuit by overcoming what? The internal resistance. So definitely some work is required or some energy is required to overcome internal resistance, right? Okay, for understanding, say some 5 joule. Okay, 5 joule is required to overcome the internal resistance. Then only current will develop in the internal circuit or inside the cell. So how much is available outside? Just 25. 30 minus 5, 25. And that is what? That is terminal voltage. Terminal voltage is the potential difference available across the terminal of battery when current flows through the circuit. Clear, right? Okay, I explained this much to get a clear idea about EMF and terminal voltage. For this particular question, no need to write this much. Okay, you can just write the paragraph seen in the screen. So 30 joule is the EMF here and 25 joule is the terminal voltage. 30 joule is the maximum work which can do by a battery, but only 25 joule is available for outside when current flows through it. So 25 is the terminal voltage. Clear, right? For this particular question, this is what you are supposed to write, okay? EMF is the potential difference between the terminal of battery when no current is flowing. And that is the maximum work a battery can do. On the other hand, terminal voltage is the actual potential difference available across the battery terminal when current flows through it. As some of the energy is used for overcoming the internal resistance, the terminal voltage will be always lesser than what? EMF. Clear, right? Two cells of EMF, 1.5 volt and 2 volt, having internal resistance 0.2 ohm and 0.3 ohm respectively, are connected in parallel. Calculate the EMF and internal resistance of the equivalent cell. See, for parallel combination, we know the equation for E net and R net, right? What is the equation for E net? It is E1 R2 plus E2 R1 by R2 plus R1, right? So what is that? 1.5 into, what is R2 value? 0.3 plus what is E2 value? 2 into, what is R1 value? 0.2 by 0.2 plus 0.3. Right, on calculating, you will get 1.7 volt. Easy calculation. Okay, that's why I'm not doing. Now R net. See, R1, R2. So R1 is what? 0.2 into 0.3 by R1 plus R2. So 0.2 plus 0.3. Okay, R1 is 0.2 and R2 is 0.3. Okay. On calculating, you will get 0.12 ohm. So we got the answer. So we finish 10 questions. Okay, 10 most important questions connected with cells. Okay, so you revise this. You can expect this question directly for your board exams and term exams. All the best to all of my students.